Hey, I'm Micah. I'm going to show you how to break the laws of Minecraft physics. From duplicating blocks, to duplicating items, to obtaining water in the nether dimension. And I'm going to show you how this furnace can help explain how we're able to do all of it in the latest version of the game, Minecraft 26.1. Because this singular furnace is the fastest experience farm in Minecraft. Let's talk about Entity ID suppression. Entity ID suppression, conceptually, is really simple. Cause the game to crash, but in a controlled manner. All of the lines of code that happened before the crash will have happened, and all of the lines of code that were supposed to happen after the crash just won't. Where in the game code we cause this crash affects what we can do to the game, because making Minecraft just not do things in a way we can control is very powerful. Entity ID suppression, as you can tell by the name, uses entity IDs to cause a controlled game crash. When Minecraft is launched, it creates a number in memory, which we'll call the current entity ID, starting at 0. When the game creates a new entity, that number is increased, given to the entity, and added to a list of entities for Minecraft to keep track of. For example, when a zombie is spawned into the world, the current entity ID is increased, given to the zombie, and the zombie is added to the list of tracked entities. This happens for all entities created in the game. When an entity is killed, despawned, unloaded, or otherwise removed, Minecraft removes that entity from its list of tracked entities. For example, if this zombie died, the zombie will be removed from the list. So this begs the question, what happens if an entity is added to the list, but it has the same ID as another entity that's already in the list? Which one does Minecraft keep track of? Well, in this case, the zombie doesn't get added to the list, the game crashes before it can, because Mojang literally told it to. If the entity is already in the list, then crash the game. That's literally the code. Mojang just tells your game to crash, and so it does. So, how do we do this? Well, we can't just make the current entity ID go down, so that the next entity that's created will collide with an existing one and crash the game. But we can make it go up by creating entities. And computers don't have infinite RAM, so there's a limit to how much that number can increase. Let's use an analogy. Imagine we have 5 digits to store the current entity ID. So, in this example, the entity ID can go from 0 to just below 100,000. So, what happens if we create an entity in this state? Well, 99,999 plus 1 is 100,000. But we don't have space for this 1, we only have 5 digits. So 99,999 plus 1, in this example, is 0. This is called an integer overflow. We can do this to the current entity ID number, but in binary, with 32 digits. That means that we need to create this many entities. That's over 4 billion. So, we need to create over 4 billion entities. And do it actually within our lifetime, and without lagging out the server. This is where chunk loading can help us. The Minecraft world is actually split up into 16 by 16 block areas called chunks. How many chunks are rendered around the player is controlled by the render distance setting, with larger numbers allowing you to see farther distances, and smaller numbers allowing you to see shorter distances. So long as your simulation distance setting is greater than or equal to the render distance value, the ring of chunks directly outside of what you can see are called lazy chunks. In these chunks, the game no longer processes entities, but still processes redstone. In a ring around the lazy chunks, you'll find the border chunks. In these chunks, the game knows that the blocks and entities exist, and that's about it. Nothing else happens there. Only outside of these border chunks, we find chunks that are not loaded at all. So if we have entities in a border chunk, they won't be processed, which will cause a lot less lag than the same entities in a fully loaded chunk, where Minecraft has to process the physics of those entities. If we put entities in this unloaded chunk, then load this chunk as a border chunk, Minecraft will create the entities in this chunk, incrementing the current entity ID. But those entities won't be processed as they're in a border chunk, so we won't lag out the server. Then, if we unload this chunk, Minecraft will forget about those entities, allowing us to recreate them later. Minecraft runs its physics and logic 20 times per second, which means if we alternate unloading and loading this chunk 20 times per second, we can create the entities in this chunk 10 times per second. Alright, so let's make the setup. We have to get entities into this unloaded chunk. I like to do that using dispensers here with snowballs in them, because snowballs are cheap and easy to get. And we can put a wall in front of them so that when we're done using the setup and the chunk is fully loaded again, the snowballs will instantly run into the wall, making the cleanup afterwards easy. This setup with a minecart will constantly keep this pressure plate held down, but only if it's in a fully loaded chunk. When this minecart enters a lazy chunk, it will stop hitting the pressure plate, allowing this torch burnout clock to start. We can put this here to dispense all of our snowballs. So now, when we're here, the minecart will be fully loaded, stopping our snowballs from being dispensed. But when we move here, the minecart will enter a lazy chunk, so our snowballs will be dispensed into the border chunk. Since the snowballs are in a border chunk, they aren't processed and won't run into the wall. And since the redstone is in a lazy chunk, the redstone can still be processed. Once our snowballs are finished dispensing, we can move to here, which puts the snowballs in an unloaded chunk. A dispenser can hold 144 snowballs, a hopper can hold 80 snowballs, and a shulker box can hold 432 snowballs. So that's 656 snowballs per dispenser. So with 16 shulker boxes feeding into each of our 16 dispensers, we'll have 10,496 snowballs in the chunk. We load the chunk 10 times per second, so that's 104,960 entities created per second. That'll get us to our over 4 billion number in just over 40,920 seconds, which is a little less than 11.5 hours. You can add more entities to the chunk to overflow the current entity ID faster, but you have to be careful, because with too many entities, you'll start lagging the server, and in some cases, even if you're not lagging, the chunk can't finish unloading in the 1/20th of a second before the next chunk load, so that next chunk load won't be able to create the entities, as the game hasn't forgotten about them yet. How many you can get away with is dependent on your server hardware, and some other factors, like whether sync chunk rights in the server.properties file of your Minecraft server is set to false, because if it is, then you can get away with more entities and overflow faster. Setting region file compression to none has a similar effect, but it's less impactful. Also, the less blocks that are in a chunk, the better, as there's just less to load. The easiest thing to do will be to build it in the end dimension over a void chunk. I just find that this many entities is a good trade-off between not taking forever and working on pretty much any server. So, we have our entities in the chunk, but we need to load and unload that chunk as a border chunk 10 times per second. The setup for that is stupidly simple. It's literally just an observer clock and some redstone dust. When we activate the piston, the observer will observe that and turn on. Despite the fact that the redstone dust it's powering is in a border chunk, which doesn't process redstone, it's being powered from a lazy chunk, which does process redstone, so this redstone dust will still turn on, which reaches all the way up here. Redstone dust actually updates the blocks around it up to 2 blocks away, which, for this top dust, looks like this. However, Minecraft can't update this block because that block isn't loaded. So to remedy this, Minecraft loads the chunk as a border chunk for 1/20th of a second, creating our entities. 1/20th of a second later, and our dust hasn't changed, so it doesn't load the chunk, and the previous chunk load is over, so the chunk unloads, so Minecraft forgets the entities. Another 20th of a second later, and the observer from the lazy chunk turns off the redstone dust. This causes the same block updates from before, including this block, so the chunk loads again. And this just repeats on a loop, loading the chunk as a border chunk 10 times per second. This setup with the block updates from redstone dust only works if your server's simulation distance is greater than or equal to the render distance, because if it isn't, the redstone dust won't be able to reach the chunk with the entities in it. If that's the case on your server, you can just load the setup with a Perl instead of with a player. So, we know how to increase the current entity ID very fast, but how do we know what it currently is? If you're in multiplayer, one option is to log out and log back in, which will assign you a new entity ID based on whatever the current entity ID is. Then you can just hold F3+C for 10 seconds to crash your client. The entity ID that was assigned to you will show up in the crash report, right here. You can now relaunch the game and rejoin the server with your newfound knowledge of what the current entity ID is. Okay, maybe we need a better way. How about this? We'll put a pet, or a villager, in this unloaded chunk down here. Then, to check the current entity ID, we can load it in, which will give it a brand new entity ID based on whatever the current entity ID is, and then we can kill it, which will show its death in the game logs, with the entity ID that was assigned to it right here. If you're okay with modifying your client, the server does just tell you the entity ID of every entity you see. So you could just look at the incoming packets from the server and update your guess for what the current entity ID is every time you see a new entity. Doing that will give you a much better real-time reading of what the current entity ID is, but it's technically not vanilla. I did write a mod which does this, and I'll leave it in the description. Let's return to the furnace. This furnace has smelted 2,477 cactus into green dye. A furnace that has smelted this much cactus will produce an experience orb with the maximum possible experience value when the item is taken out of the furnace. This singular experience orb is capable of bringing you from level 0 to level 37. So we can create an entity, keep it loaded the entire time while we overflow the current entity ID all the way around, then take the green dye out of the furnace. The experience orb this generates is an entity, and is therefore given an entity ID. And that entity ID collides with the existing entity's entity ID, so the game will crash before the experience orb can be tracked. But you may have noticed that, I didn't crash! This is because taking a green dye out of a furnace is a player action. If a crash happens directly as the result of a player action, your game won't actually crash. The code that was supposed to happen after the crash still won't happen, so the experience orb is left in a state where it was created, but it wasn't added to the tracked entity list. An experience orb in this state is invisible to the player because the code that was supposed to tell us that it exists just didn't run. But we're still able to pick up this invisible experience orb, and every time we do, it's unable to be removed, so we can pick it up over and over, forever, at the maximum absorption rate. This is the fastest experience farm in Minecraft. It's important to note that random entities that spawn into the world, like zombies, skeletons, creepers, etc., can collide with an existing entity and will actually crash your server, so you have to be very careful to do the thing you want to suppress before that can happen. All of the entities needed to cause the suppression don't need to be loaded all at once. All we care about is increasing the number of entities spawned since the server started. So all you technically have to do to cause the suppression is just launch the game, keep an entity loaded, like yourself, and just wait long enough. Eventually, enough entities on the server will have been created such that the current entity ID gets back to 0, and the moment an entity is created that collides with an existing one's ID, the game will crash. It's genuinely a miracle that servers aren't just randomly crashing from this. To mitigate random mob spawns like this, we could use a buffer. For example, what if, instead of smelting 2,477 cactus into green dye in this furnace, we smelted 100 times that much cactus? That way, when we take the green dye out of the furnace, we create 100 experience orbs. In that case, we can take the green dye out of the furnace just barely before we make it back around to 0, and there's a pretty good chance that at least one of those 100 experience orbs will collide with the existing entity. Experience orbs aren't the only entity we can suppress. This is an entity ID suppressor. The way that it works is by creating a bunch of floating rails, so when any of them are updated, over 700 entities are created, giving us plenty of buffer for at least one of those to collide with the existing entity. This suppresses block updates, which can do plenty of interesting things, including breaking the obsidian of a nether portal without breaking the actual portal blocks, duplicating blocks by suppressing the placement of the blocks, although this won't duplicate the data of those blocks like the contents of shulkers, and we can do plenty of other things. Using a setup like this, we can create a floating comparator. Then, by putting an item into an item frame behind it, we cause a comparator update, making the comparator pop off, creating an item. Suppressing that item creation, or any other entity created from that comparator popping off, will duplicate whatever you put in the item frame, including its data, so you can use this to duplicate shulkers. With the same floating comparator setup, we can make a shadow stack. This is a stack of items on the ground that literally are the same stack of items that are in this furnace here. The same items exist in two places at once. Throwing them out of my inventory also makes them disappear from the stack on the ground. These are really cool, and you should check out Igna's video on the topic for more details on this. I'll leave it in the description. When a falling scaffolding block lands, it will first look for a place to land, and if that landing spot is in water, it will first set the falling scaffolding entity to be waterlogged, then actually land as a block, then remove the waterlogged entity. Normally, these two lines of code happen right after each other, so we never see the waterlogged falling scaffolding. But crashing the game in between these two lines of code when it lands, with a butted TNT block to create an entity, for example, allows us to keep the waterlogged falling scaffolding as an entity, and thanks to 1.21 mechanics, we can send that entity through a nether portal and let it land in the nether, giving us water in the nether. Once you have water in the nether, you can create more of it with kelp, like this, and move it around with observer-pulsed sticky pistons. Be careful, because longer pulses, or regular pistons, or pulling the water will destroy it. For a nether-compatible infinite water source, you could build something like this. Now, each time you want a new water source, place a waterloggable block here, push it out, and move it wherever you want with flying machines, like this. Lava flows faster in the nether, so making a cobblestone generator in the nether is literally just inherently faster than making one in the overworld. If your water is stuck against the bedrock of the nether roof, you can use this setup that JKM showed me with a headless piston like this to pull it up off the floor without destroying it. This machine, by Eagle from Ott, is able to create dolphin highways for your nether roof with your newfound nether water. This could be an incredibly unique way to get around your world. By loading entities in the nether that have the same entity ID as the player, you can crash the game after the player has entered the nether, but before the player has gotten the advancement for entering the nether, meaning you can skip the "we need to go deeper" advancement. The same thing works for the end, too. This means that technically, beating the game with truly 0 advancements is actually possible. In versions of the game where sound suppression or class cast exception suppression still exist, both of them being other update suppressions that require another suppressor to create them, this suppression can provide a much easier way to create them than causing an out-of-memory error. Check out Igna's videos on those two suppression methods for more information on them. So that's Entity ID suppression. Entity ID suppression was originally discovered by Katie and myself back in July of last year, and entirely independently discovered by Lily, or Aspargus2, who told us a week before this video comes out. Update suppression methods in newer versions of the game have largely been gatekept by the technical community to keep them from being patched by Mojang. By releasing this, I'm almost certainly going to cause this update suppression to be patched. However, I think gatekeeping tech like this forever is kind of cringe, so while I'm probably dooming the suppression to be patched, I've held onto it for long enough, and I think people should know that it exists. As much as I want people to know about the suppression, I did just kind of teach you how to crash any server you want. Please use this knowledge responsibly. In the future, I plan on making more videos showcasing and explaining more cool Minecraft tech. If you want to support me in doing that, you can check out my Ko-Fi, which I'll leave in the description. The music for this video was created by Draconian Music, who I'll also leave in the description. You should go check them out, they make really good stuff.
I can only count to 4 billion. I can only count to 4. I can only count to 4. I can only count to 4. All the balls. 2. Start observer clock. 3. Calls it chunker load. 4. Can count no more. 1. Entity is fold. 2. Break a block with torch. 3. Java exception. Fraud! I can only count to 4. 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 Billion. 294,967,296. Shout out to all 32-bit integers. I love you guys. We wouldn't be here if it wasn't for you. Also, huge thanks to Mojang for implementing this code. This is one of the exceptions of all time. Thank you.